Welcome to this second video tutorial of Let's Make a Point-and-Click game for the Atari Falcon. This tutorial uses the FGDL library available in the description below. This library facilitates the programming of games and demo for the Atari Falcon, taking care of the screen setup, hardware scrolling, GIF image loading, sprites using the blitter, the sound mixer, joystick, mouse, keyboard, Cinepack video playback and much more. In this tutorial we will review all the functionality of the FGDL library to see how to use them step by step. In the provided FGDL library, you have the C headers which provides you with all the functions available with some explanation. The library precompiled for the standard Falcon 68030 CPU. And for the CT60 accelerator card with the 68060 CPU, and a tool for Cinepack video conversion. There is two tutorials available, one for the standard Falcon and one for the CT60 accelerator card. In this tutorial we will review the first tutorial for creating the base of a point-and-click game for the standard Atari Falcon. First of all, the graphic GIF files all share the same palette. Because we will use the paletted screen mode, 256 colors. The index 0 of the palette must be the transparent color for the sprite, so that the library can generate the transparent mask automatically. Be careful that the index 0 color will be the screen border color, so we want this color to be white or black, for example, at least for the palette that will be loaded as the main palette. But this can be another color such as pink, for example, for the sprites to distinguish the transparent part. Let's get back to the code part. First we will initialize the library. As we can see in the FGDL header, the FGDL init function allows you to start the FGDL library by setting up some flags about the video mode you want to use. You can select three video modes: 320 by 240 in 8 bits or 16 bits colors mode, or 640 by 480 in 8 bits colors mode, 256 colors paletted. You can also specify if you want a double or triple screen buffer. The double buffer mode allows you to work on a screen buffer while the second buffer is shown on screen. Avoid tearing effects. The triple buffer mode is used for intensive and variable computation, like in demos, for example if the computation takes less than the time of a frame. You can start working on the third screen buffer and not wait for the V-blank screen synchronization. The FGDL init function also takes two more parameters, max width and max height, which are the size of the virtual screen if you want to use the hardware scrolling feature. This will allocate a bigger screen buffer. This feature have a width limitation due to the Falcon hardware, that is specified here in the comments. For now we will stick with a standard 320 by 240 screen and a single screen buffer. The FGDL init function will return a string of the error that occurred if any, or null if everything went all right. Once we have set up the initialization of the library, we can access the current screen buffer using this variable. FGDL current screen pointer. We can include the GIF library to load an image file. You just have to use the GIF load function, with the GIF file name. A width and height pointer to get the GIF width and height, not mandatory. You can set null pointers. The palette pointer to store the palette data, not mandatory. You can set a null pointer. And finally the last parameter is if you want to convert the final image raw data into planar. The way the Atari screen works is that the pixels are arranged in a planar way, instead of a chunky way, like on PC. The standard chunky way of storing pixels is that, in 8 bits mode, each pixels takes 1 byte to store, in 16 bits it takes 2 bytes. The Atari screen in 16 bits true color mode works this way, but the palette mode 1, 2, 4 and 8 bits works in a different way in planar mode. All video images are stored in memory in 16 bits interleaved format. The video chip grabs 16 bits at a time from each plane present as shown in the following diagram, which represents a 16-color, 4-plane, screen layout. The first 16 bits of the screen data will be the bit 0 of the first 16 pixels, followed by the bit 1 of the first 16 pixels, etc. Depending on how many bit per plane mode you selected for this video mode. I will not go into details about this, as the FGDL functions takes care of this for you, so just pass the true value in this convert underscore to underscore planar field. Once we loaded our GIF file, and after making an error check. We can transfer this data into the screen buffer using a simple mem copy. And set the screen palette using the GIF palette using the FGDL set palette function. Then we just wait for a keyboard key to be pressed. And then we exit the library to restore the computer at the initial state. We now compile the program and test it on the Falcon via Atari emulator. The next video will talk about how to use the blitter to show a sprite with transparent masking and use the mouse.